It changed from red to yellow.
It's from the red, right?
So it's
Okay.
acidic, yeah.
Okay, we're gonna talk about these. Let's do the easy ones first.
Okay.
So this is Star Chowder.
Ew.
What do you mean?
Oh, sorry.
So can you see which one is positive? So these are Myra's plates. So you guys are gonna look at your own plates in a minute. Okay, this one's positive, this one's negative. That discoloration is because the iodine has been there a little bit and now it's beginning to dissipate. Okay? So this is positive for the breakdown of starch. This is negative. This is the production of amylase, which breaks down, which radiates around the colony, and it's destroying or breaking down all the starch, and so there's a clear zone around the colony. You're going to add iodine, enough iodine to cover the entire surface of the plate, but not so much that like you'll make the colonies float in the water, or I'm sorry, in the iodine. Okay. You got it? Okay. So next plate is, I don't need this, is the skim milk agar. And so I think it's going to be easy for you to tell which one's positive.
Yes.
This one's positive, this is negative. The organisms that are on here, it's Bacillus subtilis, is this Bacillus? It is breaking down the protein casein, which is the major protein in milk. I can't believe everybody. I feel like there was a movie called Weird Science a whole bunch of long time ago.
Yeah, that's the 80s.
Science.
Yeah.
You're too young to know that.
I'm
But anyway, so this one's positive, that one's negative. Okay, breakdown of casein. And then my favorite place is not here. Where is it? These are examples of skim milk. And intermediate. Hey Myra, what happened to
Starch
the
hydrolysis.
No.
Hydrolysis is the first
what
one, right?
happened to the
This one,
the milk.
yeah.
This is
Starch
the
hydrolysis
yeah.
is the first one.
That was a skim milk.
That's
The top, the one on
yeah.
top, right?
Yeah, I'm looking for the bottom. What's the bottom one?
The starch.
The bottom should be the starch hydrolysis.
This is the SMA, yeah, the
That's what I'm
skim.
saying.
Okay. This is the lipid hydrolysis. And so you're gonna have to look at an angle to see the clearing right around here. See it? No clearing here, but you can see the clearing there. You might be able to tell if we put it like this, you might be able to tell a little bit better.
Oh, wow.
So you can see the clearing around there. But more importantly, if you smell this,
Yeah.
it smells like cheese.
I don't want to. It's gonna like.
It's also Staph aureus is producing this really
Oh, wow.
Wow, it does smell like cheese.
So it's just really like very small
Mhm.
change.
because we put it in the refrigerator very quickly,
Oh.
so I didn't have
it's
time to
not
go crazy.
Sorry, Marie.
I love cheese too much. I don't want to smell it. You're gonna ruin cheese for me.
Oh, what the hell?
Is that cool?
It smells like dog food.
Ew.
Yeah, it smells like dog
I
food.
don't know what dog food you've been.
What do you feed your dogs?
She's like
Purina.
cheese. Velveeta.
All right, so let's talk about these guys. So let's do the carbohydrate fermentation test. So can you all appreciate that on this one, that the organism is fermentative in every single nutrient?
Yes.
Yeah.
How do you know it's fermentative?
Because it changed
It's got
together
gas.
and it has gas.
It's yellow and it's got gas in the durum tube. That's fermentative. Okay?
So
You can, true or false, you can only have fermentation in an acidic environment.
true.
True. So if I ask that on an exam food practical, then you better know it.
So it's only fermented if there's gas.
Correct.
If there's no gas, there's no fermentation.
Right.
Even if it changes to
If it
yellow.
if it's yellow, it's just acidic.
Oh.
Okay. So let me look at another one. How about this one for the prions? They have a different biochemical profile. Oh, this is great.
Oh.
See the difference here?
They're pretty.
So, what can you tell? So I think we can all agree that this one is what color?
Red.
Red. Or pink.
Pink, so
Oh, yeah, I
it's
like that.
more
Basic.
basic.
It's
It's
okay.
more basic, okay? Now, these two are a little harder, but one of them is a little more yellow than the other. Which one?
The one on your
This
left.
one. So this is going acidic, so it's acidic. This one is neutral. There's no change here. Okay? So on a practical, I would have to say you're looking at a red or orange color. I might say something like you're looking to something that appears to be turning yellow. So if that's the case, it's going to be acidic. But fermentation or not?
No, there's
Just
no gas.
acidic. Okay. You two could be microbiologists. All right, so Prions, you did a great job.
Thank you.
Now let's look at the other one. The other one's really easy. You might be able to tell already which one is positive if I just shake it a little bit. Which one's positive? This one right here. All right. This one, the organisms are put in here, but it did not.
Oh my
It did-
god.
Don't do this unless you know what you're doing. This one, it repolymerized. This one, I'm not going to do that because it'll fall and get me all dirty. But this one's completely liquid. See? Any liquid is positive. So you should take a picture of them like this. And the one on top is negative.
Oh, do that one more time.
The one on
and say
top,
cheese.
the one on the
Say
bottom.
cheese.
Say cheese.
Oh, does that mean it's taking photo?
Yeah, it is.
Oh, okay, dang, I took 1,000.
That looks better actually. So you can see it against the shirt.
Oh,
Everybody got it? Okay, so I want you guys to spend about 5 minutes collecting data, talking about the test. You can even spend 10 minutes, and then we'll do the new stuff. The new stuff is going to take me longer to talk about than it is for you guys to inoculate, and then we'll call it a day. This,
I like it.
like you can see my smile.
Dang,
All right.
I didn't even know that they took all those photos.
Keon, are you carrying it around without a rack? Oh, Keon.
Dog it, Keon.
All right, so today we're gonna do 4 inoculations, but we're gonna get 6 pieces of data. Okay, these 4 tests, what we call MVIC up there, MVIC. The I stands for indole, the M stands for methyl red, the V stands for Bose-Proskauer. The little I means nothing; it's just there so it makes a nice word, MVIC. And the C stands for citrate. Okay, so here these tests are. Let's talk about the SIM first. The SIM is what has the test for indole in it, but you can also test for 2 other things. We got smart after a while. We just stopped doing indole tests by themselves and started doing all these 3 tests because you could get 3 pieces of information from 1 test. This is a motility medium. So how are you going to inoculate it?
With the needle.
With a straight needle. Okay? And so two of the characteristics or 2 of the results can be acquired just by looking at the tube when we come back on Thursday. Number 1, is there any black precipitate in it? If there's black precipitate in it, that means that the protein has been broken down to the microorganism. There is a little bit of ferrous ammonium sulfate in here, also known as iron. That iron will react with the hydrogen sulfide and produce a black precipitate. Black precipitate indicates that hydrogen sulfide has been produced by the microbe. Okay? So it's binary. Black positive, not black negative. Okay? The other thing is motility. And so you can look at it, and if it's growing only at the site of inoculation, negative. If it's growing a little bit away from the site of inoculation, positive. So those can be looked at really quickly. The third one, yes ma'am?
You can't really see it if it turns black though, can
You can't really see what?
you? If it turns all black.
That's right. So for the scope of this course, if we take it and it turns all black, we're going to assume it's modal.
Okay.
But it's not true because the gas permeates the entire media and it's going to react with the iron that's in the media, so it's going to turn completely black. You would have to do an additional motility test to do that. But for the scope of this course, right, we're teaching, we're not really doing analyses, we're learning how to do analyses. If it's black, it's going to be completely black, and we're just going to assume it's modal because the organisms that we've selected are all modal, that are hydrogen sulfide positive. Okay, that's going to be Proteus and Salmonella. Citrobacter. Okay? Good? Good. All right, so the third test is for indole. So in here is some tryptophan. What's tryptophan?
Makes you go night-night.
Huh? Makes you go night-night. Okay, good. But what is it? It's an amino acid, right? So so there is some controversy. Does it really make you go night-night?
Really.
But mostly it does. It's really important for everything circadian. Hunger, sleep patterns.
It like takes that away.
No, it
Enhances it.
libido. I'm not gonna go on after that.
Does it
okay?
really?
Mm.
Where do you get this?
Anyway, so listen. So on here, in order to figure out whether or not it's going to be positive for the breakdown of tryptophan to indole, right? Do you want to see the reaction?
Yes, it's the
No?
It turns.
red, right? The red light.
Oh no, I'm talking about the molecular reaction.
Oh,
Oh.
absolutely then. Oh, you don't.
Oh, in
Oh,
words?
that.
No, not in words. I don't.
I thought you were gonna.
I thought he had a sample.
I thought you did too.
That's not fun.
Oh, it's a chain. Okay.
That's
How many
less
carbons, how
exciting,
many
yeah.
hydrogens, how many oxygens?
It's organic chemistry.
That is correct, Mundo, my favorite.
It's not.
This is indole, and this is pyruvate.
Organic chemistry is really hard.
No, it's not. That's the reaction. We're looking for this thing right here.
I wanted to see the red lake.
Okay. Okay. And we can test for that colorimetrically. You gotta remember the structure.
No, how can you still remember that?
Because it's fun. Science is fun, Keon.
No,
Once
organic
you get
chemistry it's the only memorizing.
No, it's not.
It is.
Oh, It's synthesis. Okay, so what you do here then is you're gonna add about 5 to 8 drops of Kovacs reagent.
So is that gonna be on our test?
Yes.
That
No,
way?
No, that?
No.
No.
Oh, okay, cool.
Bonus?
No, because Keon will stop doing everything.
Keep trying,
I
okay?
tried
Keep
to.
trying.
So listen, you add about 5 to 8 drops of Kovac. What does the GTTS stand for?
Drops.
Drops. very good. So you add about 5 to 8 drops. If there's a red light that appears, that's positive. If there's no red that appears, it's negative. Okay? So when we come back on Thursday to look at these, I'm going to show you how I want you to report and record the data, the results. Okay? Any questions about SIM? Okay. Let's go to the next two. Oh, somebody messed with my two. So the next two, the MR and the VP, are run in tandem. What does that mean? Always together. Always together. So the two tubes, each of them have glucose in them as a major substrate. To one, you're going to inoculate a set, an MR and a VP with 2 organisms, E. coli in one, and you have another set you're going to put Enterobacter aerogenes
In both.
in both tubes.
One organism in both tubes.
Correct.
Okay.
Okay? You're going to treat them, you're going to treat the set of E. coli and the set of Enterobacter aerogenes separate.
But they do different things, right?
They do different things. But it's the same substrate.
They
Right.
produce different end products.
They do. So what you do then is you inoculate them. You come back after 24 hours, and to the tube labeled MR, you're going to add about 5 to 8 drops of methyl red. If it turns red, then it's positive for acid and products.
So do you put it in the temperature for 24 hours and then take it out, or you leave it in there until we come back? Or what-
You put it in there. It's
Does it
not going to
matter?
change anything. You
Oh,
can leave it
okay.
in there 48 hours.
Oh, okay.
Okay? So we're looking for, does it turn red? If it turns red, then the organism broke down glucose to an acid end product, some acid. Succinic acid, lactic, it could be a whole bunch. Okay? But you still have to run the other test.
Right.
You run the other test, and you come back in 24 hours, and to this tube that's labeled VP, you're going to add about 15 drops of potassium hydroxide and about 8 drops of naphthol. Naphthol is a serious carcinogen and a mutagen. Do not eat it, Gio. It takes 15 minutes for the reaction to happen, and I am impatient. So we're going to add a catalyst. The catalyst is creatine. Do not steal my creatine because you want to have more muscles. Okay? So it will cut it down to about 5 minutes. This one will turn red, but it's going to be more of a burgundy red, like A&M red. Kind of like that color right there on the shirt. Okay, good?
You said tripping with me? Because I got on a Texas State shirt? No.
No.
A&M.
So, no. But listen, the color between Texas State and A&M is a little different, right? But anyway. So, but you have to look at both of these tubes together. It's got a built-in quality control mechanism. Okay, so, Chescanator, go to the board with the black pen, please. So if you have a result that's MR positive and VP negative, what is the result? Acidic. Very good. Who said that? Look at you. If you have a result that's MR negative, VP negative, what is it? Neutral. No, no.
You said negative, negative?
No, I said negative positive. Hello.
Oh, I thought he said
I
that
could have
too.
swore he just said.
I thought that's what I heard too.
Because I'm Hispanic, you're making fun of me? Okay. Good. MR negative, VP negative. If it's not acid and it's not neutral, what is it? There you go. And then if you have positive, it's an error.
What?
Dang, girl.
I got that dance on camera.
You can never have one organism with the same substrate produce two different end products, except for one. But it produces around a 6.93 pH, and that's so close to neutral that it tests positive for both of them. If you get that organism when you're working, you'll understand, because you're gonna be confused. What the hell is going on? Okay. Good. Anybody have any questions about how the MR and the VP tests are performed, how they're evaluated, and what the results mean? Because guess what? They're going to be on the practical. Okay. Last one is the easiest one of the bunch. This is called Simmons citrate. That's a citrate. It's a slant. In here, you've got the salt of citric acid called citrate, and you've got a pH indicator called bromothiamyl blue. Bromothiamyl blue at acidic conditions is yellow, at neutral conditions is green, and at basic conditions it's blue like...
No, this is
No, not that kind of blue, no. It's blue like the aprons.
So like the lid?
Oh, yeah. Yes.
Can you hold that up again?
Thank you, Claudia, for letting me do all that and then showing me everything. All right, so the way you inoculate a slant from now on, if you're doing and you're looking for a qualitative test, these are all qualitative tests, is I want you to use a straight needle, and I want you to SSSB. What is that? SSSB stands for, take your bug, come in here, you want to streak the slant and stab the butt. Do not stab anybody else's butt. Okay? One more time. Streak the slant and stab the butt.
Okay.
Anytime you have a slant that you're looking at a qualitative test. Okay? So that's going to be the triple sugar arm that we're going to do on Thursday also. It's really important because there are some facultatively anaerobic organisms that when they get in here, they will produce a really blue area in the butt, but will not produce that blue on the slant. Okay? Anybody have any questions? Okay. So it is now about 1 o'clock. Probably 10 minutes to do all this, and then we'll call it a day. Okay?
Nice.
Questions?
Who's gonna keep up with this for Angela?
What was SSP?
SSSB, streak the slant, stab the butt.
You speak too fast. Slam the butt.
Not slam the butt.
Slant,
Streak the slant, stab the butt.
stab, butt.
It's just when you say that.
Read what?
B-U-T-T.
Are you sure?
Yes.
I would not, okay,
It's
first.
gonna be on your tail, right?
Yes.
Not stab. Stab.
Dale, quítate. Oh, sorry. No, you're good. For real.
Yeah,
All
stab.
struggling.